Hello, everyone, and welcome to this session about building a multi-cloud data platform in a tightly regulated industry. My name is Natalie Godec. I'm a staff cloud engineer at Babylon. My background is in infrastructure, systems engineering, and DevOps, and I have a particular thing for data, for security, and AI, and building new tools and new platforms. I'm also a photographer, and you can find me on Twitter and Instagram at @UVisSuite. The tag will be on every slide, so if you want to tweet out about my talk, don't hesitate to do so. A bit of background, what does Babylon do? We are a digital healthcare company on a mission to put an accessible and affordable health service into the hands of every single person on Earth. And how do we do that, you might ask? That's quite a challenge. Well, we do so by tapping into a small and ubiquitous device that pretty much everyone on the planet already has, the mobile phone. We develop applications that help our users, our members, take care of their health and choose better habits in their life through digital twin and monitor. They also can talk to a doctor wherever they are from their phone, from their application, through our telehealth and our clinical support. And also we develop AI-powered tools to provide better care, to help our users make better choices about their health, but also to help clinicians do a better job and provide better care. Now, healthcare industry takes care of a lot of data. And as a digital healthcare company that is focused on AI tools, we deal with even more data on a day-to-day basis. And now that the background is set and you understand why I'm here talking about this subject today, let's look at the challenge. Let's imagine that you are building a product and you've built a bunch of services that are running in your runtime and they need to exchange events or messages or share data with each other. You will likely need a streaming platform for that. Maybe you will choose Kafka. You don't have to, it's not the only choice, but let's say that you chose Kafka. With time, your product is growing, your services are growing and multiplying, and you need a bigger platform to host all of that. So, okay, you grow your platform, you scale it up, you scale up your event systems and your event streams. But then your product really blows up. Let's say that you are maybe the new Clubhouse or a new Pokemon Go. You have clients in multiple countries and multiple continents. They all need access to your services, and you need to deal with all of those events and provide the customers with the experience that they need while also dealing with all of their data in these different locations. That's exactly where Babylon finds itself today. We started out in the UK and also deployed in Rwanda, but now we have clients in the United States, in Canada, and in Southeast Asia. And we have to provide all of our platforms and services in a similar way everywhere. So how do you deal with that vast amount of data? How do you deal with such a vast system? Do you just scale out? Do you just make your platform bigger and provide the same service everywhere? Do you copy the services into locations where you go to? Maybe that's a bit too complex. So it's quite a challenge. Let me tell you that it's not that simple. You see, the customers that you have, they are people, they are personas, and personal information is protected to a varying degree around the globe. First of all, we have two kinds of protected information: PII, personally identifiable information, and PHI, health information. And they have different regulations and rules that you will need to adhere to should you deal with such protected information in different countries. First thing that you need to think about is data privacy. Whatever you do, however you are, whatever product you're building, privacy needs to be in the core of what you build. If you want to have the business leverage and the advantage in the current market while dealing with personal data, you will have to not only build data privacy into your systems, but also very clearly advertise that that is what you're dealing with and that's what you're doing. With the advancements of Internet of Things and the meta realities and the mixing of real and virtual worlds, more and more people are becoming aware of how companies collect and use their data to extract money from them often. And not everyone is cool with that. So you will really need to think about this from the very beginning of your product and really build data privacy into all of your systems and clearly advertise it. To ensure that you do that, a lot of countries and organizations and international associations have adopted certain regulations and certifications that companies that do deal with personal information have to adhere to. One such certification regulation is GDPR, which is in Europe, which is the act to protect personal data. And if you have ever had to deal with any clients in the European Union, you will know what it is and what it does. You also have CCPA in California, which is kind of the first American equivalent of GDPR. And it kind of made a lot of noise last year in 2021 when it was first adopted, because it was the first regulation of this kind in the United States. Also in the United States, you have HIPAA, which is the Health Information Protection Act. That's not what HIPAA stands for, but it deals with all kinds of medical data and health information. Also, you have standards like ISO 27001, which deals with data processing. And every country, every region will have their own specific regulations specific to their legislation. And sometimes they are a little bit more relaxed, but sometimes they are a little bit more tight. Like in some countries, you have a blanket rule that you only can process that data within country and on servers that are within that country, and they don't really accept or recognize that there are different layers of information that you might or might not want to protect in that way. And speaking of that, that particular way of protecting data is also known as data locality. Very, very often you will have to find a way to store the data that you have in your systems in the country that it originated from. Now, again, not every country requires that, but it is useful to assume that everybody does, because then you are building your systems in a way that can already comply with this, and you can just deploy in different locations without a problem. And the last one, if you're dealing with any sort of AI deployment and AI developments and research, you will also find yourself needing to deal with the perception of AI and AI applications in public. Now, in this talk, we're focusing on the technical aspects of things, so we will leave this one out. You will definitely have heard of it should you do any artificial intelligence and machine learning research. If you want to take out one advice out of this entire talk, then this is this. Assume the strictest data governance laws. Period. If you are doing business in different countries, it is the best bet to assume the strictest possible regulation. In that way, you will be able to build your system that adheres to that and then easily deploy to any other country. And I'm saying this because I've heard a lot from a lot of people who want to do kind of research or machine learning or AI in Europe, but they are saying that it is very, very difficult because of GDPR and the local regulations. Well, let me tell you, I see it as an advantage. If you have built your systems to adhere to that, then you can just conquer any market. Whereas if your system and your product is built for, let's say, the American market, where it's a little bit easier to deal with data, you will have to change your ways and change your systems if you want to have clients in the countries that have a tighter regulation. So it is always safe to assume that the data governance laws are the strictest you can imagine and build your systems around that. Now, this talk is about building a multi-cloud data platform. Once I was giving a talk in Switzerland, the land of chocolate, expensive watches, and private banks. And the one question that everybody asked me was, my goodness, you store health information in the cloud? It was as if it was unimaginable to them. But in fact, we already have loads of different examples in the industries that are as tightly regulated as healthcare. There are challenger banks like Monzo in the UK and N26 in Europe that have built a very robust, scalable, cloud system, cloud native system, and all of their data is stored in cloud. And with the pandemic, a lot of industries have had a big push to digitalization, including the traditional ones like healthcare. So yes, it is possible. Let's see how. This is an example of a data platform that is cloud native and multi-cloud native. It is based on what we use in Babylon. Of course, we have a lot bigger ecosystem around it, but these are kind of the main tools that I wanted to show you. We have our streaming and our services in AWS on Amazon. We use EKS for Kubernetes, which is the managed Kubernetes, and we use MSK for Kafka, which is the managed Kafka. It makes sense. They work really, really well together. And then all of the services that need a really good integration with EKS or Kafka or need a good latency are also running on AWS, such as RDS and OpenSearch and Elasticache, S3, logging, and such. And then for our big data analytics and AI, we're leveraging Google Cloud. We have our data in BigQuery and cloud storage, and then we plug all sorts of tools into that. We have our data pipelines in Cloud Composer, which is managed Airflow. Sometimes the lighter pipelines are running in Cloud Functions, which is the Google Cloud's equivalent of Lambda or just function as a service. We also have the use of AI notebooks or Kubeflow for ML and data science, and we do visualizations with Tableau and Looker. And you can see how this is very easily applicable to any system, really. AWS has really good runtime offerings, if that's what you like, and Google Cloud is really, really strong in the data offerings, if that's what you like. But there are loads of tools, so how do you choose what you're using and deploying? Well, first of all, you need to assess your own use case. Which services best fit your needs? Like I was saying, we had our runtime in AWS, so it just makes sense to have our streaming and our databases cache in AWS as well for better latency. While Google Cloud has excellent analytics tools, so we use Google Cloud for that. And also our data scientists and analysts were familiar with things like Airflow. So we use Composer, which is managed Airflow. We use Jupyter Notebooks, which is very convenient for our data scientists. And tools like Tableau and Looker that are easily deployable on Google Cloud as well. Historically, we have attempted to be cloud agnostic, but that's famously the most expensive way of running cloud. So now where it makes sense, we're using cloud native tools that provide us with the service that we need. Also, always keeping in mind that maybe we will need to switch to another cloud provider at some point. But as you do that, as you choose your tools that fit your needs, you also need to keep in mind the regulations that you need to adhere to. And luckily, cloud providers have their clients' interests in the heart of what they do. They want you to be happy to be able to use their products because they want you as their client. So what they do is they provide all of those certifications and documents that prove their regulatory requirements of their services publicly available. So you can just go on Google and just search the certifications of a particular service that you want to use. They very often publish them. They are readily available because that's very important for a lot of their clients. So they make sure that this information is accessible. You will also need to do a couple of configurations within your platforms. You will need to enable encryption at rest and encryption in transit on all services. This ensures data security when it's stored and transmitted through cloud providers. Sometimes it's enabled automatically, like on Google Cloud. Sometimes it's not, like on AWS. So you will have to make sure that whatever service that you use, you enable encryption at rest and encryption in transit. That said, don't bother with your own PKI. Don't bother creating your own keys and managing your own keys. In most cases, the way cloud providers manage the keys, rotate them, and store them securely is enough to be compliant with all of the regulations that you need. You also want to enable audit logging on all of the data access and system events. you will need to store those logs separately. And I mean separately, like in a completely separate bucket, or like in even completely separate project or account. Make sure that the access controls to those logs are restricted. And these are not your application logs to which you want to give access to developers to. These are really audit logs. And I'm saying that it's very important to secure them because some of the logs might contain sensitive information. For example, BigQuery logs the entire query in the audit logs. And sometimes, depending on how the query is composed, it might reveal some information. So it's better to really lock down access to those logs, store them for a minimum of 90 days, and you'll be good. In terms of data locality, like I said, Babylon is finding ourselves in a situation with a lot of different locations where we need to be in. And so that little diagram that I showed earlier that shows in which locations we are, well, that means that we have our platform in all of those locations. We have the deployment of our runtime AWS systems and deployment of our Google Cloud systems around the world in the locations where we operate. Is it that complex? Yes. Does that mean that we can safely work with our clients? Yes. The key to this, to managing such a platform, is to really have all of your pipelines and CI/CD and deployment automated through a sort of a code management tool or an infrastructure management tool like Terraform or CloudFormation or something like that. Now, all of that is all good. You have your architecture, you have your services, you've encrypted everything, but cloud services are still public APIs. They will be on the internet. Every resource of the cloud is just an API endpoint at the end of the day. So how do you secure that? Well, we need to talk about serverless for this. As you can imagine, in the cloud, in AWS, for example, in particular, you have VPC, which is your network, which is a private network, and you have private services that are run within your VPC, within subnets in your VPC. But at the same time, you have serverless products which are actually running not in your VPC. The way this works is that things like S3, Lambda, or CloudWatch, they run on AWS network, but not within your subnets. And when your private services need to communicate to S3 or Lambda or whatever, that communication can go over the open internet, exiting the AWS network whatsoever. So that's not really that good. It's a bit of an issue. So how do we fix that? Well, you can deploy VPC endpoints for AWS in particular. For serverless services such as S3, Lambda, and CloudWatch, you have an option to deploy a VPC endpoint, which will mean that the service is kind of pretending to be within your network. The private services that run within your subnets will be able to access those serverless services through the endpoint, and the communication stays within your network. That's good. It's the same situation for Google Cloud. You have your compute or Airflow or Kubernetes clusters that run within your VPC, but you also have storage, BigQuery, Cloud Functions, Cloud Run, and all of the wonderful serverless products that run not in your VPC. And when someone is trying to, for example, query a BigQuery dataset from their own laptop, that communication will also go over the internet, which is not great. How do we fix that? We can use a service called VPC Service Controls. It exists in Google Cloud in order to protect your APIs. What you do is you create a service perimeter and put your projects that you want to protect in it, and you list the APIs that you want to protect. If you work with data, then obviously you will want to protect storage, BigQuery, Cloud Functions, and so on. Once you've done that, that perimeter acts as a firewall on steroids. It protects your APIs based on the identity of the calls and also on the network and device parameters of the calls. So then all of the unauthorized identity or an unauthorized Google Cloud project or any call that is not explicitly allowed will be blocked. One very common use case for this is employee VPN. You might want to only allow accessing sensitive services and sensitive APIs through the office or employee VPN that your employees have. When that happens, the way this works is the DNS resolution of those APIs that are protected is changed. BigQuery is no longer accessible at bigquery.googleapis.com. It's accessible over the restricted APIs. And that goes into the restricted IP addresses, which enables Google systems to really check every call and every identity. And once that all works, all of the communication happens within the Google network, if the communication is between Google services. The way you allow specific identities and calls is via 3 different policies. You can connect different Google Cloud projects through bridges if they are in different perimeters. That is a common use case when you want to have all of your kind of runtime in one perimeter and protect that, and have your analytical perimeter where humans can go and play with data. You can also have access levels, which defines which requests are allowed based on the identity or the caller network or the device policy or anything that you want to restrict. Often we say that specific user or service account is allowed, or a specific IP address, like in the case of the employee VPN. And the latest addition to the stack is the ingress and egress policies. Sometimes you are not able to create a bridge between projects. For example, you cannot bridge projects into different organizations. In this case, you can create an ingress and egress policies on both sides if you need to, for example, enable data exchange with a partner. Also, this is used, for example, when you want to create like a global audit logging sync and you don't want or can't specifically explicitly create these access levels and bridges between the logging project and everything else in your state, then you will create egress policies and ingress policies to protect data, but only allow the logs to go out into this one specific logging project, for example. Now, how do you connect all of that? Right? Multi-cloud. How do you connect clouds? How do we make sure that our services events go safely to BigQuery? Right. If you think about it, 2 different clouds, what are they? They are subnets. How do you connect to subnets securely? You can have an IPsec tunnel. You can have like bidirectional VPN tunnels between the 2 subnets, which will ensure that the packets are going over the internet between the 2 clouds securely. The way you will do that is you will have your subnets on the AWS side and on the Google Cloud side. And you will deploy VPN gateways on both sides. You will configure those VPN gateways to talk to each other and have the same identifications and the same parameters in order to establish a secure connection. The VPN gateway on the AWS side will publish BGP records into its subnets. The VPN gateway on the Google Cloud side through Cloud Router will route all of those requests into your subnet in Google Cloud. Now wait, subnet, but BigQuery is serverless, storage is serverless, loads of other services are serverless. How do you do that? Well, you see, once the call to BigQuery, let's say, reaches through VPN gateway, through Cloud Router into your subnet, it is by that point on the Google Cloud network. So from then on, the request will securely go through to the restricted APIs and be authenticated and verified in the same way we discussed previously. Now, in order for your services in AWS to know which DNS resolution to go through, remember we said that when you protect your APIs, the DNS resolution changes. Well, Google publishes the IP addresses of those restricted APIs, and that's really handy because then you can create Route 53 DNS records on the on the AWS side, where you say that bigquery.googleapis.com goes to this particular IP address. The current one is 199.36.153.4/30. But Google publishes those, and you can really create all of those routings. And at that point, your services running in your AWS subnets will know that those calls need to go to this IP address That IP address goes through the VPN gateway, through the VPN tunnels, over to Google Cloud. And the fun thing is that you only need one VPN gateway per service perimeter in Google Cloud. And it will work across all of the projects that are added to that service perimeter. Really handy. This is like the biggest thing about connecting clouds, about running a multi-cloud infrastructure, and very exciting. And if you have any questions about that, you can reach out and we can chat about it in more details. It's very, very interesting. I wanted to share with you also a little bit of the things that we are going to be working on in terms of our data platforms. You see, our platforms are really well established for the architecture that I have shown, with the runtime on one side and pouring all of the data for analytics and for the applied sciences for research on the other side. But what we don't have yet is being able to bring data from an arbitrary space back into Kafka. So if we have any data that comes in from as a result of data science or as a result of analytics, or any data that comes from our partners or public health data and stuff like that, we want to be able to bring the data back to Kafka, and we don't have a way of doing that yet. So we want to use Kafka Connect to deploy a little bit of an advanced infrastructure in that terms, and that's one of the projects that we're doing. It's going to be very interesting and very exciting in terms of security as well. How do you protect all of those pathways of data that don't exist yet? And the other one is dealing with the data locality and doing global data science. Specifically because of data locality and regulations, we can't allow global research as such. We can't just join queries of data from the UK and the US. That's not possible. So how do we do that? It's a big challenge, and it's very difficult to solve for every particular use case. We're thinking maybe federated jobs that run in different locations and then share the results of them, or something like that. But I'm personally really looking forward to architecting this particular platform and this particular network. It's going to be very interesting. And that will be all from me. Thank you very much for watching. I hope you learned a lot of new things. I hope you feel a lot more confident in building your multi-regional, multi-country, multi-cloud data platform with all of those tips and tricks. And if you were interested in all of those future projects that I mentioned, then we're hiring. Reach out to me or check out our careers page. And thank you.